G'day there everybody. I just want to do another quick one today to show you this simple wireless electricity system running on 6 and 12 volts. I have here a 3055 and I had to add a 1.5k ohm resistor to the base to get it to work. Up to about 3 kilo ohms will work. Anything less than that with this coil won't work so well. It's going to depend on the resistance in your coil though greatly, what resistor you use there. I also have connected to my base a reverse biased diode, which I can attach to with my earth clamp, which is here. I can attach that to my emitter and through there to the earth of my battery to protect the transistor from negative spikes from the collector to the base. I don't think that's actually going to be necessary. I've done a few quick tests, but it's there just in case we need it. So let's hook her up. That's without the diode. My yellow line is on the 5 volts per division scale. Let's knock that down to 2. And on 6 volts we're seeing minus about 2 volts on that base, so that's nothing too serious. And you'll notice that the LED is lighting up quite nicely on the receiver coil, just sitting right next to us on the bench here. Not bad range there. It's a AAA battery if you're looking for some scale. It also works sideways over the top of the coil quite nicely on one side. If you put it directly on top of the coil, it's really bright. That's pretty much maximum brightness for both of those LEDs. They're probably doing about 2 volts at about 60 milliamps to get that kind of brightness out, maybe 40 milliamps, but they're doing a lot. And you'll notice on the scope that when you put a load nearby, the waveform does die down quite a lot. It's stealing a lot of power. The current draw from the battery will also go up. I did check that earlier. But it's got a bit of range on it, slightly increased. But the range hasn't increased heaps for the extra power. It's more that this coil's transmitter coil is slightly bigger. So I will point out that the probe on the collector here is actually on 10 times and on the 10 volts scale. So without any collector nearby, I'm seeing maxes of 22 volts and a peak to peak of 22 volts on the collector side there. So that's times 10. So there's 220 volts going through that coil. 220 volts as opposed to 30 earlier today. And while the brightness has gone up, the amps transmitted has definitely gone up, the total watts has gone up a bit. It's not heaps. I think a bigger coil is going to make a big difference. Although that was a nice find. And there is actually, if you get the right spot, there is actually a dead spot right in the middle there. We'll go through the table too quite nicely. So that's 6 volts and we're getting a bit of warmth there, but nothing too serious. So let's go for 12 volts really quickly. It does heat up pretty quick. You really want a heat sink to do this. There's 12 volts and it is brighter. There is much more stronger solid peaks. It's much more able to cope with the load of the LEDs. Brighter that way. Increased range. Quite a bit of increased range. But again, like, it's double the voltage. It's not heaps of increased range. It's not double. Nowhere near it. Better watts, definitely. Much more efficient transfer of power. Definitely works better sideways. But I think the size of the coil is going to be the most important factor in amplifying this out for bigger ranges. You don't need heaps of power. I reckon you do a lot of this with 3 volts and a bigger coil. And 3 volts, you most certainly in a big coil, you certainly wouldn't need a resistor. Just be a transistor, keep it as simple as possible. So there you go, that's 6 and 12 volts. Thanks for watching.